Alrighty, you guys, so this is going to be a pretty quick video over exam 1, or a typical first exam you're going to have in your business calculus class. This was actually real questions from my first exam, so to me this would be a pretty good template to go off of, and this covers mostly all of chapter 9, which is going to hit things like limits and derivatives, rate of change, and things of that nature. So for question 1, it says find the limit if one exists of a and b. So let's look at a first. Alright, so this one gives us a function, and it tells us to find the limit as x approaches -1. So all you're really going to do here is plug -1 in for x. So we'll go ahead and do that. Alright, so all I've done here is put -1 in for these two x values. So all that's left now is to simplify this. So -1 cubed, that's going to stay -1. And then -1 squared is going to be +1 plus 9. So we have 2 times -1, which is -2, minus 9 times +1. It's going to stay -9, and then plus 9. Alright, and then -2 minus 9 plus 9 will give you -2. And that is your answer for A. So let's bring this up a little bit and look at B. So we see that it's another limit question that gives us a function and asks us to find the limit as x approaches -2. So first off, you're going to want to try to solve this like the first one. So we're going to plug -2 in for x. So let's do that. So we have -2 squared minus 4 over -2 plus 2. So this is going to give us 4, -2 squared, minus 4, and then we're going to have -2 plus 2. So 4 minus 4 is 0. -2 plus 2 is 0. So is 0 over 0 our answer? Alright, so this is actually not your answer. So what you're going to want to do here is actually set this up a little bit different. So we're going to look at our function first. Alright, we can see that the numerator is x squared minus 4. Now, can we factor that? Is there going to be something that we can factor that would give us x2 minus 4? Of course there is. And that would be x minus 2 and x plus 2. Because x times x is x squared. X times +2 is 2x. -2 times x is -2x. So those two will cancel each other out. And you're left with -2 times 2, which is -4. So this is the correct factor of that. And then we'll go ahead and bring our x plus 2 over. Alright, so we can see that we have an x plus 2 in the numerator and an x plus 2 in the denominator. So those will cancel each other out. So this leaves us with just x minus 2. Now we can go ahead and plug -2 in for x. So this gives us -2 minus 2, which equals -4. And that's your answer. Alright, question 2 states that for f of x equal to x squared plus x minus 12, find the average rate of change over the interval -1 and 10. Alright, so we're looking for the average rate of change for this function at these 2 points. So since these are two separate x values, I'm going to go ahead and label them as such. We'll label -1 as x1 and 10 as x2. Because what we're going to end up doing is plugging these values into the function and getting a y output. So let's go ahead and do that. So for the first one, we have f of x equals x squared plus x minus 12. For this one, we're plugging in -1. So we have -1 squared plus -1 minus 12. So this will give us -1 squared is +1 plus -1 minus 12. 1 plus -1 is 0, and all we're left with is -12. Alright, so this is going to be our first y value, -12. So let's find our second one. So our function is f of x equals x squared plus x minus 12. We'll go ahead and plug in 10. So that will be 10 squared plus 10 minus 12. 10 squared is 100 plus 10 minus 12, which gives us 98. Alright, so we found our y2 value. Now we're looking for the average rate of change. Alrighty guys, I was starting to run out of room, but anyways, so we found that our y2 value was 98, our y1 value was -12, our x1, you can say x2 value was 10, and our x1 value was -1. Alright, with these values, we can actually find a rate of change using this formula. y2 minus y1 equals x2 minus x1. You probably remember this. Alright, so let's go ahead and fill those in. So we have 98 minus -12. That would be over 10 minus -1. And the double negative becomes positive, so we have 110. And then the same thing on the bottom, which gives you 11. So you can actually simplify this even further. 110 divided by 11 equals 10. And so that will be the average rate of change for your function.